Hi, welcome to my YouTube channel. I am discussing solid state physics concepts. So in last video I discussed crystal systems. So I discussed 7 crystal systems and 14 Bravell lattices. So I given one shortcut in that video, CTORHFT, C for cubic, T for tetragonal, O for orthogonal, rhombohedral, hexagonal, monoclinic, triclinic. These are 7 crystal systems. For Bravell lattices, 14 Bravell lattices, that is the order is 3 2 4 1 1 2 1. So this is simple to remember. Crystal systems, 7 crystal systems, 14 Bravell lattices. So here in this video I want to discuss one more concept, crystal translation vectors. Crystal translation vectors. See, so translation vectors. See, in the words, in language of crystals, we say that in such a way, in such a way, the crystal there exists some small group of atoms. In every crystal, a group of smallest group of atoms, that is pattern unit. That is pattern unit repeats itself to form a big crystal. So in any crystal, some smallest group of atoms structure that is repeats itself in three-dimensional. So it gives a big crystal. So that is smallest group of atoms that we can call as pattern unit. Pattern unit. So how it extends in three-dimensional? How it extends depends on translation vector. Crystal translation vector. So we can write like this: T equal to N1A, N2B, N3C. These are vectors. See, N1, N2, N3 are integers. Integers. A, B, C are vectors. So this is T is nothing but translation vector. Translation vector. So see, the n1, n2, n3 are integers. So in direction A, in direction B, in direction C, it will extend by that pattern unit, the smallest group of atoms extends in three-dimensional way. It gives a full form of crystal. So this is just what is translation. Crystal translation vector I discussed here. T equal to n1A, n2B, n3C. See here, n1, n2, n3 are integers, a, b, c are vectors. So this is simple concept I discussed here. Then I am moving to one dimensional lattice. What is one dimensional lattice? So already I discussed in the last video one dimensional lattice, 1D lattice. So 1D lattice is a group of regular arrangement of points in one dimension. So this is, for example, take copper. This is a lattice point. At the lattice point exists only one atom. So monolattice, that is in one dimensional lattice. One dimensional lattice. So here, so it is extending only like this. In only one direction, unidirection it is extending. So here this is the place, place, placing between two atoms. So according to translation vector, just we have to keep n1a, n1a. See, there is no integer n2, there is no n2 equal to 0, then n3 equal to 0, because it extending in only one direction. It extending only in one direction. That's why I removed n2 and n3 integers. So n2 equal to 0, n3 equal to, it is only moving. For example, it is moving, extending in x direction. Take n1a only. So this is translation. What are the properties? Properties for this. What are the properties? See, for this one, only one Bravell lattice Breve lattice exists. For this one dimensional lattice, it has only one Breve lattice. Then for what about unit cell? Breve lattice only one, unit cell. What about unit cell? Unit cell is only line. Unit cell is only line. See, for one dimensional lattice, it has only one Breve lattice. Then what about unit cell? Unit cell shape, that is only a line only unit cell. Then what about nearest neighbor? So third property here, nearest neighbor. Right, I can write here, nearest neighbor. Nearest neighbor. So nearest neighbor, take one atom here. What is the nearest? So only the nearest atom is this one only. This one only. Nearest neighbor, that is two nearest neighbors are 2. The nearest neighbor distance is A only. Nearest number of nearest neighbors 2. So for example, this is U. I taken this one. For this one, nearest neighbors are 2, 1 and 2. What about nearest neighbor distance? A. Number of nearest neighbors 2. Distance of nearest neighbor, distance is A. Distance is A only. Next, for example, this is n-dimensional lattice. So nth atomic lattice. For example, copper atoms, n number of are there. Then what about number of nearest neighbors? For n-dimensional, not n-dimensional, unidimensional, but n atoms lattice. So number of nearest neighbors, that is equal to n into n number of neighbors will be n into A. The number of nearest neighbor is 2. Nearest neighbors are 2, but number of nth number of nearest neighbors. Nearest neighbor distance Na, number of nearest neighbors is 2. For example, n copper atoms are existing, n number. The distance of nearest neighbor, nth number nearest neighbor Na, number of nearest neighbors is 2. So I will clarify here. For example, copper atoms are n are there, if exist n. So number of nearest neighbors is 2 only, but the distance of nth neighbor distance, the distance between nth neighbor, that is n into A. Nearest neighbor distance A only, but nth number nearest distance Na, nearest number of nearest neighbors is 2. So I discussed in this video. So these things only I discussed, only what is translation vector. So I applied for one dimensional lattice here. For one dimensional lattice, it has only one Breve lattice. Then what about unit cell for one dimensional lattice? Unit cell for one dimensional lattice is a line. So what about nearest neighbors? Nearest neighbors for one dimensional lattice is 2. Then what about nearest neighbor distance, that is A. For example, it is n number of copper atoms if it is there in one dimensional lattice. So what about nearest neighbor? Number of nearest neighbors is 2 only, but the distance of nearest neighbor, that is nth atom nearest neighbor, that is equal to n into A. Nth nearest neighbor distance, nth nearest neighbor distance, that is equal to n into A. For example, two atoms exist, that nth nearest neighbor distance, that is equal to 2A. Okay, thank you. So I will discuss one more topic in the next video.